Okay, so now let's go and work a net ionic equation together. So I want you to work this along with me. First of all we have here is potassium iodide reacts with lead 2 nitrate. So we have to be able to write the reactants and predict the products and then classify if it's soluble or insoluble. From there, we can then write our total ionic equation as well as our net ionic equation. So when we're writing these compounds, we say we have potassium, which is a +1 charge. We have iodine, which is a minus charge. Sorry, my dog has the zoomies. Let me pause it and get her to shut up. Okay, sorry about that. All right, so we have potassium, which is a plus charge, iodine, which is a minus charge. So when I crisscross those, it's going to be Ki, and that's going to be the way that looks. Lead 2 nitrate, the way I write that, this 2 is giving you the charge of lead, so that is a +2. And nitrate is NO3 minus, so it has a -1 charge. Now when I write this compound, it's going to be Pb. This 2 is going to crisscross to the nitrate, and the 1 is going to crisscross to the lead. So when I crisscross to a polyatomic ion, we make sure that we put that polyatomic ion in parentheses like so. So this would be lead 2 nitrate. So that's the first thing you need to be able to do. Write these reactants correctly. Now we get to write our products. So what we're going to have is the potassium is our cation, the lead is our cation, and the iodine and the nitrate are our anions. So these guys are going to switch partners. Now, when we switch partners, we switch according to charge. We don't translate these subscripts because that's going to come in from the balancing. So I'm going to have potassium and nitrate come together. So that's a K plus and an NO3 minus. So it's just going to be KNO3. Let's see if I can do that there. And then we are going to have Pb2 plus, remember cations first, Pb2 plus and I. So our other product is going to be Pb. The 2 is going to crisscross to the I, so it's going to be PbI2. So these are our products. Now, obviously, this isn't how you write a reaction. It's just so I can have enough room here. This is what you'll actually see here. So what I have at the very beginning is Ki plus PbNO3 yields KNO3 plus PbI2. So that is our equation that we have there. Now, before we do anything else, we need to make sure that that equation is balanced. You see how we have 2 nitrates here and 2 iodines here. So we have to be able to balance this out to make sure that we have the same amount on both the reactant and the product side. So that's why potassium iodide here gets a 2 coefficient, and potassium nitrate gets a 2 coefficient as well. So now we have a balanced equation. Now the next thing that we're going to do is classify these as whether or not they are soluble or insoluble. If you refer to your solubility rules, group 1s are always soluble, so this is aqueous. Nitrates are always soluble, so this is aqueous. We have a group 1 and a nitrate, so that's aqueous. And then this other product here, lead 2 iodide. We have a rule for iodine, but lead is one of those exceptions. So this compound here is soluble. Is a solid. It will be your precipitate. Is classified as insoluble. So now that we know our solubility rules and we've classified these as to what they are, we then can write our total ionic equation, which shows what it's actually doing when we pour these two together. So if it's aqueous, then we split apart into its separate ions, and notice how I have the proper coefficients here to keep that reaction balanced. And then I have my aqueous potassium nitrate here. And then the lead 2 iodide stays together because it is a solid, it is not aqueous, so we don't separate it into its ions. So now we're getting ready to where we get to cross out our spectators and we get to actually write our net ionic equation. So let me get that set up for you. Okay, so if we look at our total ionic equation, we have to be able to cross out our spectator ions. And we get to cross them out if it remains unchanged as a reactant into its product. So let's look at potassium here. Potassium is its ion aqueous form as a reactant, and it's also in the aqueous form as a product. So that means that it remains unchanged. If so, I get to cross it out as a spectator. The iodine is an ion here, but it is not in the product side because it remains that solid compound. So we do not get to cross out the iodine. Lead is doing the same thing. It is an ion here, but then it's in the compound as a solid here, so it's changing. We cannot cross out that. And then the nitrate is an ion here, and it's the ion in this section as well. So we do get to cross this out as well. It's remaining unchanged from the reactants to the products. So we have two spectators here. Potassium ion is a spectator, and the nitrate ion is a spectator as well. Since we've crossed out our spectators, we then get to move on to our net ionic equation. So our net ionic equation for this one is Pb2 plus 2I minus, bringing it down, you see the things we don't cross out, yields Pbi2. And we write a little s there to denote that that is our solid, that is our precipitate. So this is the process that we go through whenever we are writing net ionic equations. For AP, you always have to write net ionic equations for every question that you're working with, especially if it's free response. So I hope that helps some. We're going to work some more in class, and thank you for tuning in.